Okay, so we're going to take a look at horizontal slides of exponential graphs. So we have an h being applied to the x, so it's sort of an exponent. So a little h applied to the x means that we're basically, if we take a look at Desmos, we can see what it actually does. It moves the graph right or left. So we always sort of do it in relation to where, if there was no slide, where the graph would be. And we always know that an exponential graph crosses through 0 and 1 initially. And then if we apply a slide to it, an h value, then if we go, say, to -2, that's to the right 2, and +2 is to the left 2. So that's what it does. Now, how do we figure out what that is if we've given a graph? Basically, all we do is we plot the point at 0, 1, like we normally do. And all we do from there is, because it's only a slide right or left, there's nothing else that's been applied, we just move till we basically hit the graph. And where that point is tells us what the slide has been. So this is a slide of -2. So when we write it, we want y is equal to a to the x. And it's always opposite, so if it's -2, it's going to be +2. Let me ignore that. X plus 2. And then you can find a, because if you know a point, 0 and 4, you can just stuff that in for y and x, and you can find your a. All right? So always plot your 0, 1. And then again, on this one, if I plot 0, 1 right here, and then I'm going to move over to this position here to hit the next point, that's been a move of 3, so I'm going to get y is equal to a times x, and it's going to be opposite, so it's going to be that. And then again, I can use a point on the graph, some exact point that I'm really comfortable with. It could be like 5 and 4 or whatever, and plug that in for y and x to get what your a is. Now, when times are a little bit more complicated, when we've got 2 slides that have basically gone on. So if we have, make that a little h, probably not going to be able to, but there's a little bracket there, it should be a bracket there. So we've got a slide right and left, and we've got a move up and down. Now the move up and down is what you want to find first, because that's the easiest thing to find, and it's just based on what your graph is approaching but never quite touching. And so in this case, my asymptote is sort of here along here, so B is 2. So once we've got that much of the equation. But we now need to know if what h is, what the slide has been right or left. So this is what you do. You plot your point at 0, 1. And then what you do is you go 1 above. You move 1 above where the asymptote is. So if the asymptote is at 2, right here, we go from 0, 1, we go up until we're 1 above where the asymptote is. And then all we do is we move over till we hit the next point, which is here. So what we've done is we've put 0, 1 and plotted that, and then we've moved up until we're 1 above the asymptote, and then moved to hit the next point where the graph is. That's at -1. That is a move of -1, and to the left 1. So when we write that, it's going to be y is equal to a, x, and it's always the opposite, so it's +1, and then +2. So those are the shifts, right and left and up and down. And to find the a, that base number there, just plug in a point for x and y, whatever you know an exact point, could be 0 and 4 for this one or whatever, and plug it in to find your a. So let's try the other one over here. So 0 and 1, the asymptote for this one is at 1, so it's a bit tricky, but this one's at 1, so there's the asymptote, so that's my b is 1. And then we just move till we get 1 above that, which is right here. We move from there to here, and then we go over, and wherever that ends up, that's going to be my h. So that's +3, so h is plus 3, so we're going to write it in the equation y is equal to a. And it's going to be the opposite, x minus 3, and that's plus 1, up 1. And that's how it works.